Hello everyone, welcome to section 2 titled Creating Game Mechanics. In this section we're first going to create a base character class that we'll be using for our player and enemies. Then we will be creating our main character Zippy and adding functionality for his movement. We'll then look at implementing controls so that we can control our player. Next we'll create an enemy that we'll be able to defeat in the game. And finally we'll add collectibles for our player to collect. This video is titled Creating a Base Character Class. In this video we'll be creating a base character class that all our characters in our game will inherit from. So let's start by updating Animated Sprite. Go to your Solution Explorer, and in Engine.shared, go to Graphics, Drawables and Animated Sprite. We're going to need to change some of the private fields to be protected so that we can use them in our character class. First there's the FPS, then the UVs, the elapsed time, the change time, the current frame, and the end behavior. Next we need to change the update method to be virtual so that we can override it in the character class. So go down to the update method. Make the method virtual. We're going to be using it in our character class to set the position of the character at the physics body's position. We also need to make a slight alteration to the code that calls onEndReached. We'll be extracting it out into a separate method so that we can override it. So go after the update method. Create a new protected virtual void called checkBounds. In here we're going to add the check from the update method which checks if the frames have gone out of bounds. If it is, we call onEndReached. Now in the update method remove the two calls to onEndReached and then call checkBounds. Now we need to make two more methods, virtual and protected. First, the onEndReach method. We're going to make that a protected virtual method. Then we need to go down to the canUpdate and we need to make this virtual as well. Now we can make the character class. Go to your Solution Explorer and go to Game.shared. Add a new folder into Game.shared. Call it Characters. Then right click on the new folder, select Add and select Class. We'll name the class Character. Make the class a public abstract method and make it a subclass of Animated Sprite. For the animations, our character is going to work by defining the start frame and the end frame for each animation, as well as a string for the reference name of the animation. So first we're going to create a struct called Animation Frames. This struct is going to have the start frame and the end frame fields. We're then going to define a constructor which sets the two values in the body. Now let's add the rest of the fields for the class. We need to define how much health the character has, so we're going to add a protected single for this. Then we add a dictionary for the animations. The dictionary will have a string for the reference and an animation frames for the value. So when we want to change an animation, we'll pass in a reference name which will set the start frame and the end frame for the animation. Next we define the current playing animation. Now we need to define the physics bodies for our characters. Our characters will be made of two physics bodies, the square body and the wheel. The body is going to sit above the wheel and they'll be linked together with a revolute joint. The joint will be used to rotate the wheel, which will make the character move. The wheel acts as the feet of the character. So we're going to add a body called main body and we're going to add another body called wheel. We then add a revolute joint called connecting joint. Finally we add values for the wheel radius and the wheel circumference. Now we're going to add a couple of properties. First we need to know which collision category this character is so that we can handle the collision correctly. So we add an abstract property to get the character. Next we add the property for whether or not the character is active. Now let's move on to the methods. Let's start with the constructor. We're going to have the same parameters as the anim sprite as well as a vector2 for the body scale. So the parameters should be the canvas, the Z order, the texture, the image width and height, the number of frames, the FPS, and the vector2 for the scale. The scale is used for the size of the physics body, as it should not take into account any white space around the asset, so we shrink the size down with the scale value. We need to add an abstract method now that we can call in the constructor. Add an abstract void called add animations. We'll be using this to add our animation frames to the dictionary. Now, back in the constructor, we're going to call the add animations method first. Now, our character should always have an idle animation at least defined. So we're going to check if the animation has the idle animation, and if it doesn't, we're going to throw in an exception to say that the character should have an idle animation. Then we set the current animation to be idle. Then we set the offset of the character so that it's always center aligned. Next, we're going to create the two physics bodies. First, we need to calculate the height of the box to be the box height minus the radius, and then we multiply it by the body scale. Then we set the box position so that it can be centered. Now we create the body with the physics world at its position, as well as the width times the scale and the box height. We set the body type to be dynamic, as it will be affected by forces. We then set the collision category using the abstract property. We set the restitution to 0 so that it doesn't bounce. And then we set the friction. Finally, we set the user data to be the character so that when we check the collisions, we can react accordingly. Next, we need to create the wheel. We first set the radius so that it's half the width times by the body scale. We create the wheel using the physics world now, and we set the position to be below the box. For the wheel, the body type is set to dynamic again, and we set the collision category. We set the restitution to 0 and we set the friction to 1, and then we assign the user data again. We then need to calculate the wheel circumference. We need this so that we can set the speed correctly for the wheel. Now we need to make sure that the body doesn't collide with the wheel. So we call ignore collision on both the body and the wheel, passing in the other as an argument. When the wheel rotates, we don't want the body to rotate, so we set the body to have a fixed rotation. Next, we need to add the collision delegates for both the bodies. I'm going to start with the main body one. So add a protected virtual boolean called onBodyCollision with two fixtures as parameters and the contact for the type of contact for the collision. This method returns a boolean, which if true, stops the object moving, otherwise it passes through the object. In the body, we check if the category is the platform category, and if it is, we return true. Otherwise we return false. This stops the character from falling through the floor. We need to also add a method for the wheel, so add another protected virtual boolean called onWheelCollision this time, with the same arguments as before. This method performs the same actions in that it checks for the category and returns true if it's the platform, otherwise it returns false. Now we need to add these methods to the delegates for both bodies, so go back to the constructor, and after we set the fixed rotation, set the onCollision for the body and the wheel. Now we can create the joint. Use the physics world to create a new revolute joint with the body and wheel, and set the position to be vector2 0. In the joint we then set collide connected to false, so that the body and the wheel don't collide. The next method we need to add is one that sets the start position of the character. After you define the two collision methods, create a new method called setStartPosition with a vector2 for the position. In this method we first convert the position to the physics world position, and then we set the position on both the body and the wheel. We're going to create another method now called updatePosition, which we are going to use to set the position of the sprite based on the main body's position. Create a new public virtual void called updatePosition. In here we're first going to convert the position to display units. We set the position of the animated sprite after and set the rotation. Now go back to the setStartPosition. After we set the physics body's position, we're going to call updatePosition. We're then going to override the update method, and in here we're going to call updatePosition again. We need to be able to damage our character now, so we're going to create a damage method. Create a new public virtual void called damage and have a single for damage as a parameter. This method will decrease the character's health, and if there's no more health left, it will perform the death logic. We now need to add another abstract method called onDeath, which will perform when the health is depleted, so we add this here. Then in the damage method we check if the health is below or equal to 0 and we call onDef if it is. Next we need to add a method to change the animation. Add the change animation method with a string for the animation. In the method we first check if the animation contains the key for the animation. In the method we check if the animation contains a key for the animation. And if it doesn't, we throw a new argument exception to say that the given animation does not exist. Then we set the current animation and then we set the current frame to be the start frame. Now all we have left for this class is to override the methods in the animated sprite. First we override the canUpdate method, which just returns whether or not the character is active. Next we override the checkBounds method. In here we need to check the bounds of the current animation rather than the entire animation. So we check for the current animation end frame and the current animation start frame. If any of these statements are reached, then we call onEndReached. Next we need to override onEndReached. In this method we again need to use the current animation start and end frames rather than the actual animated sprite's start and end. So first for the loop we check if the FPS is greater than 0, and if it is we set the current frame to the start frame of the current animation. Otherwise we set it to the end frame of the current animation. Next for the reverse we check if the FPS is greater than 0, and if it is we set it to either 0 or the end frame -1, whichever one is bigger. If the FPS is less than 0 we set the current frame to be the smallest between the start frame +1 and the end of the UVs. Finally, if the end behavior is stop, we set the current frame to be the end frame or the start frame of the animation based on the FPS. We then call onComplete with the animated sprite. The last thing we need to do is dispose of the character. So override the dispose method. In here we first dispose of the base, and then we clear the animations. And if the main body exists, we remove it from the physics world, and the same with the wheel, and then also with the joint. So we've now created a base character class. The character uses a wheel to move across platforms and can be affected by forces. It's also made up of multiple animations that we can change when we need to.